So what about then if we perhaps dive inside this a little bit and start to think about particular characteristics? An obvious one is we've dealt with things like strength and power in some of those measures we referred to earlier on. What about muscle fibers and growth? Well, if we take, say, a muscle biopsy and we take it from a quadriceps, so it has, take it from a man, and they have a range from about 3,500 to 7,500 micrometers squared, and in of women, what you get is the size is about 2,000 to 5,000 micrometers squared. So that's men and women. Now, not surprisingly, there is limited data on children for all sorts of reasons, mostly to do with ethical stuff here, really, with this. But what we understand is that the ratio of muscle cross-sectional area to that of the fibre is the same as found for adults. So this is important. It's not that the area is the same, but the ratio of cross-sectional area to the fibres is the same. So it tells us that the number of fibres remain constant during development. So that's really important. There isn't a sudden increase in the number of muscle fibers. And what we know when we start to think about muscle growth, it requires the deposition of proteins, and it occurs in two ways. One, you get an increase in the amount of protein synthesized per unit of DNA, and two, you get satellite cell nuclei division. Okay, and it's incorporated into existing cells rather than forming new cells. So this is in essence how we get growth. And actually we get satellite cell division in adults as well. But this explains why we see changes in things like strength, the strength capabilities that we referred to earlier on, at different points in childhood development. So here we can see some muscle fibers. These are under the microscope. And these just really show us we can see, if you look inside, so if you pick here, what you can see is you can see a series of sarcomeres, and you can see these in series, and then you can see them in parallel. And of course, what you can see is you can see the light and dark bands showing you the actin and the myosin filaments. It's just kind of a nice representation of what you would see under the electron microscope. Now, what happens though if we now compare this in terms of muscle fiber growth? So this is cross-sectional area. So here we've got at 8 months. So here's our fiber at 8 months. Okay. Now look at it at 5 years. So what you're seeing is almost a doubling in cross-sectional area. If we go to 14 years, it's probably twice as big again. And by the time you get to adult, it's at least twice the size again. So the key thing is, and it really lends itself to that basic understanding of muscle physiology, that what we're getting is we're getting a hypertrophy, we're not getting a hyperplasia. But it's a pretty rapid increase from 8 months to 5 years. I mean, it's pretty startling, that growth that's there. It's probably actually over double, isn't it, what you can see there? It's almost certainly probably a doubling from 5 to 14 years, particularly as you go through that growth spurt. And then finally, as you go into adulthood, there's probably that doubling again. And of course, don't forget, beyond adulthood, we start to get an atrophy. We start, particularly in older age, we get sarcopenic effect, and we start to lose cross-sectional area size. So how does this then relate to something like strength? Well, very few muscles have fibers and that simply run from end to end. And I think this is a really important point. Characteristically, you look in a textbook and they'll draw a muscle, and you'll see the fibers running very neatly. They'll draw them kind of horizontally, and that's kind of a representation. But that's not the way fibers lie. What we know is they insert obliquely into the tendons at angles, anything from 10 to 20 degrees. And so that has an impact on the force that is transmitted by the tendon, and it's somewhat less than is generated by the muscle, but it also has an impact. This isn't just for children, this is also for adults. It also has an impact, that lying of the fibers has an impact on where the predominance of muscle growth takes. If you apply the force to the same oblique angle as the fibres are lying, then you'll get a uniform increase in force across those fibres. However, if you don't apply them to that same oblique angle, but you fundamentally apply them, say, let's say more vertically, the force is coming more vertically, then anything which is at the extremes of that force that's being applied will not develop as well as anything which is more central to where that force is being applied. And so this kind of explains why, for example, using machine weights is less effective than using, for example, Olympic lifting in both adults and in children. But where it gets fascinating is what this is referring to, this oblique angle here, is what's called the angle of pennation. It's this reflection of the connectivity primarily between the fibres and a Z disc. And what we start to understand is that that angle of pennation starts to change as we move through childhood. And that's fundamentally a reflection of the growth of the individual in terms of the bones and the bony tissue and also the muscle tissue, but also the change in the cross-sectional area. It changes that connectivity. So the angle that we get, the kind of the greatest strength gains, changes as we start to grow, which actually therefore reflects as implications on the way in which we use strength training with children. It's not to say that we can't use strength training with children, but it's actually suggesting that we have to think about maybe using exercises that reflect the changing characteristics of the child compared to what you see in an adult, where those characteristics are no longer changing. Well, what we know is in childhood, there is, as we saw, a steady increase in strength, but there's little difference between boys and girls until we get to puberty. And then when we see both sexes show a significant increase in the velocity of the strength gain. So you get a spurt, that bit like we saw with peak height velocity. But we know that boys get a significant greater gain in strength, much more disproportionate than you see in females. But we also show boys get this increase in fine strength than girls, and it's a disproportionate increase in upper limb musculature, and it reaches a final strength that is very nearly double that in young women. It's quite interesting. So upper body strength is developing more than lower body strength in males compared to females. And you think, well, why might that be the case? Is it the case that young boys are engaged in more activities, potentially, that are more upper body orientated? It doesn't even have to be sport or classic physical activity. Is it the nature of being male and the activities they are involved in that promotes that kind of adaptation that we're referring to here? But most studies emphasize the fact that in sharp contrast to girls, there is a major increase in strength of boys during puberty. So in girls, we don't see that. And of course, fundamentally, the driving factor here in boys is they start to get the surge in testosterone, which is associated with puberty and the onset of adolescence, and also the release of growth hormone. And fundamentally, they are building blocks, hormonally building blocks in terms of muscle growth. And muscle growth then translates itself across into muscle strength. So if we look at this data here, there's a really nice little data set to help us. So what you've got, here we've got quadriceps strength, and it's years from the peak height velocity. Okay, so here's our peak height velocity at 0, and then we've kind of got 1 year post or 1 year before, and on the right panel we've got biceps strength. Okay, and what you've got is the circles of the boys and the squares of the girls. So what you see is at peak height velocity, where the boys get the growth spurt, suddenly, because of the hormonal changes we were just referring to, they get a significant increase in quadriceps strength. This is an acceleration. Quadriceps strength increases in girls beyond peak height velocity, but it remains at a constant rate. So they're still accelerating, but the boys get a greater gain. And you see the same here in biceps strength. The girls, their rate of increase is steady, it is uniform, it is linear. In males, beyond peak height velocity, you get an acceleration. And again, it lends itself to the fact that in the males, they're getting that surge in testosterone, and they're getting that surge in growth hormone, which contributes to this degree of development.